Inclined projection. When you throw a ball into the air at an angle theta to the horizontal, it rises to a certain height and then falls back down, landing some distance away. The ball moves in two directions at once, horizontally forward due to the initial velocity, vertically up and down due to the pull of gravity. These two motions combine to form a curved path called a trajectory. Examples of such projectile motion are 1. Cannonball. When fired from a cannon, the cannonball travels along a parabolic path. It rises and reaches a highest point and then falls onto its target. This is a classic example of projectile warfare. 2. Catapult and trebuchet. Ancient warfare. In medieval battles, catapults hurled stones or flaming projectiles in a curved path towards enemy walls or troops. Water jet from a fountain or hose. Water projected at an angle forms a curved stream before falling due to gravity. Basketball shot. When a player shoots the ball towards the basket, the ball follows a parabolic arc before dropping into the hoop. Inclined projection refers to the motion of a projectile launched at an angle theta to the horizontal with an initial velocity u. The velocity can be resolved into the horizontal and vertical direction. Initial horizontal component of the velocity Vx is equal to u cos theta. Remember that the horizontal motion is at constant velocity. Initial vertical component of the velocity Vy is equal to u sin theta, which is at constant acceleration but changes with time because it is influenced by gravity. At a time t after projection, vertical velocity Vy is given by Vy is equal to u sin theta minus gt from V is equal to u plus gt when the object is moving upward, and Vy is equal to u sin theta plus gt when the object is moving downward. At the highest point P, vertical velocity is reduced to 0. The equation becomes 0 is equal to u sin theta minus gt. Gt is equal to u sin theta. T is equal to u sin theta over g. This is the time for the projectile to get to the maximum height. The total time taken for the projectile to go up and return to the same level is t, which is equal to 2t, which is equal to 2u sin theta over g. The projectile takes equal time to move along a parabolic path and to rise and fall vertically. Maximum height h. The maximum height h is the highest vertical distance reached by the projectile. From the equation of motion, v square is equal to u square minus 2gh, where h is equal to big H. V is equal to 0 at maximum height, and the vertical component of the velocity is Vy is equal to u sin theta. Therefore, 0 is equal to u square sin square theta minus 2gh. 2gh is equal to u square sin square theta. H is equal to u square sin square theta over 2g. Range. The range is the horizontal distance between the point of projection and where it lands. It is given by r is equal to uxt. The horizontal component of the velocity ux is equal to u cos theta, and t is equal to 2u sin theta over g. Substituting for ux and t, the equation becomes r is equal to u cos theta times 2u sin theta over g. R is equal to 2u square sin theta cos theta over g. From trigonometry, 2 sin theta cos theta is equal to sin 2 theta. R therefore is equal to u square sin 2 theta over g. From the diagram, the range is least when theta is 10 degrees and 80 degrees, but maximum when theta is 45 degrees. Since sin 2 times 45 degrees is equal to 1, range maximum is equal to u square over g. The speed of projection. The higher the speed, the greater the range. Question. A ball is projected from the ground with a velocity of 40 meters per second at an angle of 30 degrees to the horizontal. Calculate 1. The time of flight. 2. The maximum height reached. 3. The horizontal range of the projectile. Take g is equal to 9.8 meters per second square. Given velocity is equal to 40 meters per second, theta is equal to 30 degrees. G is equal to 9.8 meters per second square. Number 1. Time of flight. T is equal to 2u sin theta over g. Substituting the values, t is equal to 2 times 40 times sin 30 degrees over 9.8. T is equal to 80 times 0.5 divided by 9.8. T is equal to 4.082 seconds. Number 2. Calculate the maximum height reached. Maximum height h is equal to u square sin square theta over 2g. Substituting in the values, we have 40 square times sin square 30 degrees divided by 2 times 9.8. We now have 1600 times 0.5 all square divided by 19.6. Final answer 20.41 meters. Number 3, the horizontal range of the projectile. R is equal to u square sin 2 theta over g. Substituting 40 square times sin 2 times 30 degrees all divide by 9.8. R will now be equal to 1,600 times sine 60 degree divide by 9.8. R is equal to 1,600 times 0.8660 divide by 9.8. Final answer R is equal to 141.39 meters. Time of flight is equal to 4.082 seconds. Maximum height 20.41 meters. Horizontal range 141.39 meters. I would love to hear from you. If you have any question, you can drop them at the comment section below and I will respond to them as soon as possible. See you in our next class.